So as part of, AI and all that sort of fun stuff, I also asked AI to make my presentation. So it decided that a red and blue kind of presentation was what was going on today. So we'll start with that. So the title of this, if you joined, hopefully, is from YouTube to search engine, building a fully searchable video with AI in Azure. So we're leveraging AI technologies to enhance a video searchability. If you don't know me, I'm Alec Harrison. I like to build stuff with AI. I blog at eitl.ai. And I have a podcast called Engineer in the Loop where we talk about just technology in general, typically in the Microsoft ecosystem. But my goal is to basically showcase what I'm learning. So hopefully you can learn something or take things back to your organization. Or if there's just like side projects you're doing that's like, hey, that's cool. AI is now possibly the right answer for that. The goal of this project was basically a lot of organizations and companies have AI or have video content that is hard to surface or search. So, if you start building a catalog of videos, you very quickly, especially if it's an instructional type video, get inundated with data of how do I find the exact repair procedure I need? How do I find the exact content I need? Have I covered this? Do I have conflicting sources? All these things are kind of hard to measure or check out unless you go in and start watching each video. Or even if you potentially know the right video, maybe you're on a particular step of something, you have to go through and then say, hey, now I need to watch this 20-minute video just to get to timestamp 15 minutes for the exact section or part I need. Um, and I think it's no secret, a lot of our attention spans are smaller. We have things like TikTok, those kind of things that sitting through very long content isn't necessarily something we all want to do. So the goal of this is to transform video content so you can turn full videos into fully searchable, leveraging AI and cloud so that we can, use very little configuration or training. We don't have to build our own models to do this. We want it to be semantic and scalable. So as we add more videos, we don't want the whole system to fall over on itself. And then we want a user-friendly search experience. Um, so like I said, we want to be able to do natural language queries to ask specific questions of the video content. We want AI-powered indexing, so that way we can make it easy to figure out what we're asking about, find stuff, integrate with different things. We use Python for the indexing and a lot of the data preparation, and then enhance video interaction, so transforming passive video into interactive experiences by making the content easily searchable and navigable. The technology stack, AI search and indexing. So we used Azure AI to actually store the data in there. Azure OpenAI is what we use for the embedding model, and it's also what we used for the actual chatbot that we'll showcase as well that actually does the searching. Azure AI Speech, that's used for making the transcriptions of the WAV files or WAV files, depending on how you want to pronounce those. We use the static apps for front end. I did that just because it was super easy to deploy raw HTML to, and then I can also use a super easy thing like a password for protecting it. So I can just say, okay, here's the password I'm going to use. I can go out to it, and that way people can go and edit it, look at it. I can share it with potentially business users or other people without having to do any sort of complex stuff behind the scenes. And then we use Azure Cloud. This is the Azure user group. That's kind of a no-brainer, I think. You can do a lot of this same stuff too if you're in a different cloud in AWS, GCP. Insert your flavor of choice. A lot of them are pretty feature parity at this point, especially for something like this. So the process flow we have is we'll start the process. I have a PowerShell script to actually start the deployment to Azure. That will then populate all env values we have or need throughout the process. So I basically exported all those data from my bicep file to then populate all that. We'll use Python with YouTube DLP to actually download the files from YouTube into an MP4 format. Then we have to convert them to a WAV file. So Azure AI Search Transcription Service does not support MP4s today. So because of that, we converted it to WAV files or WAV files. That was one of the file formats it processed. Then we process the videos to turn them from that to a transcription, so an SRT file format. Then we use that to save the chunks by timestamp. So by default, what it will do is trying to look at utterances. But one thing that I noticed was an issue was you'd potentially have the same timestamp but multiple entries in your SRT file. And that gets a little bit annoying if you're trying to say like what time was this spoken, which is when we get to the searching piece. So what I did was basically if it's still in the same timestamp that we're already in, we're just going to keep appending to the bottom. And I'll showcase what that kind of looks like. Then we check if the index exists in AI search. If it doesn't, we will create it. Then we chunk the data by timestamp. We'll deploy it to our Azure Static Web App. We'll search our videos, go to the exact point, and the process is over. Is there any questions on where we are so far? If not, that's totally okay. Give me just a second here. I'm going to pull this up in the browser. Hopefully the static web app still works. It's not super reassuring when it takes you to a blank page. Might have to redeploy this. So like I said, we start with deploy.sh. What this does is it actually looks in here. We'll start the deployment of our Azure infrastructure to see, hey, does this work? And that will set up all the infrastructure we have. So if I come over to here, pull up the portal, just show some of the resources I'm talking about. So if we come here, we have our different AI Foundry projects. So you can deploy some models via Bicep to AI Foundry. The issue is not all models are fully deployable via that. So like GPT-5, I believe, was not, for example. And why that's a problem is that if you want to use that model, you can't actually do a programmatic deploy. You'd have to go into the portal and actually hit deploy, which is frustrating. And then we have our form recognizer that's being used behind the scenes to chunk the SRT file. So it's actually reading the textual file itself. Our search service, this is where all of our data is stored that we actually search from. Our speech service that was used to actually take it and chunk the actual audio, so speech, to text. And then the YouTube transcription down here, static web app, which is also the storage account, that's being used to actually host the front end we built. So the process for building this wasn't super crazy. I actually used AI as a kind of a pair programmer for this, which was fun. I'm not a huge Python guy. I don't know Python super well, so don't judge me if this isn't the best Python in the world. But AI wrote a good chunk of this. So what I'm doing to start with is we deploy our infrastructure. I'm going to first see if my resource group exists. So this will handle all of the deployment, even to the resource group level. We'll create a new deployment group. And then this is me getting all my keys and credentials and exporting them out so we can do all of that. That just basically sets up the next phase of this. Then I created a pipeline.sh script that runs all of my Python commands. So the first one is download.py. What that does is it uses yt.dlp, which is a package that basically can impersonate you on YouTube. So it can use cookies in your browser to actually go out and start fetching the videos. If you don't do that, you can potentially be blocked by YouTube's algorithm because it sees it as a bot. But this package allows you to download all the files. That will then download them all into MP4 format, and then we convert them to a WAV format in here as well. Once that is done, we process the videos. So this actually takes them and I believe converts them to, and it's in here somewhere. Ignition started. Speech key, MP3 to WAV. So this is where it actually does the convert to the WAV file, my bad. and then it transcribes them. But it also go in here and check so that we can get, if we go to the transcription folder, an SRT like this. So if you didn't do this, the spot I was talking about, sometimes you get things like this, which makes it really difficult to search because, okay, I want to search, my name is, every time Tim Kramer says his name or something like that, that's spread across multiple things. And what we're going to end up wanting to do is take this timestamp here and the start timestamp. That's how we know when somebody started saying something, and it'll take them to that section. So putting all these in one chunk, then we know, okay, there's the chunk we need to look at. The other thing I did is get rid of overlap. So you can actually have token overlap, which behind the scenes is basically, you think of it like a structured data store. A token overlap would basically be something similar to this. So we could have this overlap if we think of like a structured data store. So it'd be like that. And what that's supposed to do is help you with pagination. So if you need to search for something, you can have overlap to say, oh, AI is smart enough to say, I need to go to the next document. One problem with that in a tool like this is then it might go, oh, I have the same entry if I search your organizations today. It might take me to this timestamp, and it might also take me to this timestamp, where if I come here, I would have completely missed that term. So we don't want overlap in this case. So that's just a AI thing to know when you want overlap, when you don't in chunking. Once we process the videos, then we go to data prep. I don't own any of these scripts, so they're pretty crazy. I will find the link and put it in chat. So these are Microsoft scripts. I did not write these ones. This is where some of the magic happens of converting it from our SRT file using Form Recognizer, or I think it's AI Document Analyzer or something now. They renamed it. It's still called Form Recognizer behind the scenes and a lot of stuff. It takes that and actually turns the text then to something that can be chunked and put in there. Then once that's done, I created a very simple front-end app here that will basically display all the stuff back to us. And yeah, then we can use it. So assuming all the pieces run as they should have, you can check things along the way, like for example here, my indexes. Notice I have 3,942 documents. That's just the individual chunks. I could search this. This only gives me semantic search. So you'll notice here, each little chunk of utterance I got. So the title, behind the scenes, what I did is the title was the timestamp and the content was actually the content. So again, if we look at what this looks like, it's going to say the title was this and the content is this. Why do we want to do that? So that when we come over here, and then this is a cool feature I didn't know Azure Static Web Apps had. I can show you how to enable this too. So if you're building a really low fidelity, like just super shipping stuff quickly just for feedback, you can actually come in here to, I believe it's under configuration. Yeah. So you can come in here and actually just set a password. So if you're trying to say, hey, business user, or maybe somebody external to your organization even, I'm going to demo this for you. Here's a password. Go out and just take a peek. You don't have to worry about getting them into your Entra, enabling easy auth, doing all that. There is the inherent risk of, right, like this isn't super well protected. It's only as protected as your password, but it does get you in here without having to do that. So now that I have this, I can search something like software in 2045. So LT did a talk. This is indexing the LT's YouTube channel. Scott Sauber did a talk on software development in 2045. So if you look, we have all of the things that it thinks it hit on. So you'll notice we have 2045 software. So this one is pretty confident on, and it gets progressively less confident. In the API call to Azure OpenAI, you can tell it how many references you actually want. In this particular case, we're telling it we want 5. And then it also tries to answer whatever question you have here as well. So it'll give us a little synapse on, or a synopsis on what we said. And then if I click watch on YouTube, behind the scenes, we actually convert that timestamp if I get through this ad, which is awesome. You'll notice I'm a software developer while I still have a job in 2045. That was what he read off at one point in this video. So it converts this minute, hour, seconds, milliseconds to time, which is just raw seconds in YouTube. Takes that query parameter. The other slightly magic thing we did was when I downloaded all of those videos, I actually saved off the video ID from YouTube. The reason for that is when I link out here, and actually let's just go back to the VS Code. If you notice, each of these SRT files are actually the video ID. So the reason for that is when you have a reference in Azure OpenAI, you can actually pass the file name all the way through to the front end. So in the reference payload that comes back, we should be able to see this. Let me search again. LT likes to talk a lot about TDD, so let's see if we find something in there about that. Talking about testing, been fan using Scrum. It doesn't feel super confident about this topic. That's what that message means. But if we go back here to completions, and we look at the response, we have you'll notice the content title and then file path. So that is the file name that it grabbed the data from. And then on the front end, what we're doing is essentially parsing this out and then constructing this YouTube URL. So the youtube.com watch v equals file name, and then t equals time, and then time is converted from the first part of the title to that. That then allows us to basically query any videos in our library and say, okay, tell me about this, or search this content. And then with chat interfaces, as you all probably know, the world's your limit at that point. We could continue to add more data sources. We could have other data sources other than video. So this could be, you know, we do have some blog content we could expand in here. So if you want to know about, like, I don't know, LT's offerings or LT's latest, let's look at their blog post. I don't remember what our last blog post was, but right here, how to keep AI on mission. You could search that, and then we could have multiple indexes that would also bring that up. So it would tell you if any video content match that, any text content. Where that applies in your organization is you could think of also like repair manuals, right? So maybe I have videos on how to do repair tasks or different tasks, but maybe I also have documented ways to do it. I could potentially search that, get both of those back, and then I can design how the references work. Are those two calls to two different indexes? Cool. Maybe I show the top 2 video search results and the top 2 text results. And that way somebody could cross-reference the video with the actual manual itself. You could, you know, augment that any way you see fit. And then your world's your oyster. You can just keep adding more data. Make this as productive or as specific to your company or system as you want. Anybody got any questions?
As far as cost goes, what do you think the observed cost for kind of the stuff that you're doing, like on maybe a per video basis, like what does that translate to?
Let's look. I think I can pull up costs here. So the cost right now is $30. Let me see what AI search service I'm using. What tier that really drives a lot of this. So I am using a basic SKU, which is, I believe, $79. Search. So the basic SKU is 73.73 a month. So that's a fixed cost. No matter how much data I push through it, it's going to be that. Let's go to back to cost analysis to see what we got. So that's the search cost. Azure App Service. I'm getting charged for app service. Should be able to drill into this. Why is it not? Okay. So the static site's costing me about $2 to host, it looks like. The cost of storage is less than a penny. Cognitive service is less than a penny. I should be able to get 2 per resource. I want to see daily cost. Oh, what are you doing? Cost by resource. All right, so our search service is costing us about 28 bucks so far. Our static app is costing us about 2 bucks. I don't want just November because I think there was some stuff in October too. Just want to make sure that this wasn't the embedding model, because if it was. Oh, this was the speech to text. So 22.23 was the cost of all of the videos, which we have 2, 3, 4, 5, 6, 7. I believe there was 45 as I count. So they're anywhere from 30 minutes to an hour long usually. So I'm going to say 22.23 divided by 45. It's about 50 cents per video.
Cool.
And then we did some transcription here as well, it looks like. That I think was the embedding model, so 23 cents to embed it on top of that. So for less than 30 bucks, we got it all set up and going. But yeah, the AI search instance, if you only want one index, you can get away with a free tier too. Or sorry, 3 indexes. That would substantially cut down the cost of this as well. It's just AI search is pretty expensive as a service, but it's what allows us to do this. So that unfortunately is kind of one of the fixed cost things, right? We could have probably got away with a free tier one. It just sometimes then hampers performance and all that. So I usually try to default to basic unless we have a reason to only do free. But yeah.
Alec, I'm sorry I missed the start of this. So what do you mean by indexes in this context?
Yeah, so AI search has basically, you can kind of think of them as like database tables. So like an index is basically a siloed data source or data structure. So you have indexers, that's what actually pulls the data, chunks it, and shoves it somewhere. The index is where it actually gets shoved. So for the YouTube one, for example, my fields are like this. I have these: ID, content, title, file path, URL, and metadata. So when you take the text content, chunk it up, and shove it somewhere in memory, the in memory where it's shoved is here in an index.
Okay, so you only have one index then, is that right?
Correct.
Okay.
I have one index that has almost 4,000 documents. And that's because each one of these is a document each time because of the title and content. The reason for that is when I was actually building this and running it, I didn't do that originally. I should say the cost to chunk it and embed it, all that is ×2. So if we have any costs in there, I had to do this twice because what I found was I had multiple references coming back for the same section or chunk. And that was really frustrating because then if I had one really good reference and some not so great references, they would all be filled by the really good reference. So I would have like basically this one duplicated like 5 or 6 times because that's where part of the chunk overlap and all that happened as well.
Okay.
So that reduces your document size a little bit, but for this particular use case, I didn't really want overlap because then you run into that issue. But max indices is typically what pushes you up tiers in AI search. Because if you're trying to think of like data governance, for example, there's not really a good way to govern who has access once you're in an index. So you kind of basically will query different indexes based on different users. That's kind of how you have to do data governance there. So maybe I only have a user at my company that can look at the YouTube videos, or only one that can look at these documents. Basically, I'd build an API that would then search and say, all right, in order to hit this one, you have to be this user at this level.
In order to hit that index? Is that what you're
Correct.
saying? Yeah, okay.
Yep. And then I'm going to go ahead and stop the recording for a second. So